Hi there. Welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Pedro, who has just completed the course URDF for ROS2. So he's going to give us a presentation about how he went about carrying out the project, and he will also demonstrate how he has managed to get his project to work on a real robot. So we'll connect to him and then we'll hear him speak about his project. Alright, Pedro, you can start sharing your screen and then give your presentation.
Okay.
Alright.
Request for stream.
Alright, let me allow you. There you go. Yep.
Okay.
Yes, I can see your screen now. Yeah.
Okay. First, here's my URDF. I have all the robot description here, all the links, all the joints, the gazebo plugins, and I have something different from the first task. I don't use the gazebo plugin for controlling the robot, the drive plugin. I search about the ROS control and use the control for movements too. So
Alright,
here I have
hang on, Pedro. I just want to see if if the audience can see your screen.
Oh, okay.
Because I could see it, but it's not showing nicely on the broadcast.
Okay.
Let's see. Alright, that should be fine. Let me just...
Okay.
Okay, you can go for it.
Okay. I'm starting RVs just a minute.
Alright.
Okay. So here's my URDF. As I'm explaining, I didn't use the gazebo plugin for the diff drive.
Okay.
I search about the ROS2 control and config the diff drive controller of the ROS2.
Okay.
And use it to drive the road. So here I have the configuration for the pin of the ROS2 control and all the joints that we use. And here I have the config of the ROS2 controller. So I have the diff drive that will drive my robot. This velocity controller, it's for the lidar spin that is asked. And I have this joint state broadcaster that I use for the cast wheels.
Alright.
So this is all I need. Here I have the joint state, and I set all the cast wheel joints, publishing their state. And here I have the for control movement, the wheels, and the lidar spinning.
Okay.
And after this, I take all this giant RDF and split it into Zacro files.
Okay.
So I have a Zacro for actuators, the drive motors, the chassis parts, electronics, model plugins, and something. There is the main Docker file, only 38 lines. Here I have all the includes, the other parts of the robot. In here I have a conditional include for the plugins, the gazebo plugins, and the I think the sensors is here to me. So here I have the gazebo tags, here I have the gazebo plugins, and inside the gazebo plugins I include for the sensor plugins. So once I import the gazebo plugins, I also import the sensor plugins too.
Okay.
And right here I have the launch of the controllers. I launch the diff drive that will drive the robot, velocity sliders here in the joint state publisher. Here I have a spawn for the simulation. And I need to remake the start launch file to start the gazebo because I need to include the STL files. So I search in these files that the project gives to me. I find the start script and I change some things. So here I have all the code that already exists and some things like the path for the STL files for the LiDAR and the LiDAR support. So first, and here I use so the state publisher. Here I publish the robot description. I'm using the Zero, and I declare an argument for conditionally import or not the simulation type. So I can set this USIM in the launch file, and it will pass this argument to the Zacro file and conditionally import or not the simulation. Simulation plugins there. So let me launch the robot description right here. Let me check the name. So here I'm publishing, and it's in Gazebo, RVS. I'm not seeing the rules because I'm not launching the Gazebo and controllers, so the rules are not appearing because the transforms are not published. But because I'm connected to the real robot right here, but I can share it with you the TF3.
Okay.
So I forgot the wrong comment. Generate the frames right here.
Okay, so what you're trying to show us is what the TF3 is like for this robot. Is that right?
I'm gonna show you the TF3, the merge of my TF3 from this URDF and the real robot tree that already been published.
Alright,
so here I have the TF3.
Okay.
And the two trees are connected by the base link.
Okay.
Robot start as a base link too. So here I have a base link, and then I have the real frames right here.
Okay.
And my first for chassis plate link, that is the first link I have on my DF robot. So all these other links and joints are mine from my DF.
Okay. Okay.
And they are all connected. And I still can't controlling the real robot. So if I run teleop and try to control the robot, it still obeys me.
Okay, I see.
So I use a lot of Zacro macros for things like the spacers. I declare a macro for the spacers
Yeah, yeah.
that we have. So all the things that repeat a lot of times, I have a macro. And reading the doc, I have some that I been in doubt. So I made the two things like uh, I declare right here somewhere in this physical properties.
Mm-hmm.
I declare a box, a cylinder, and a sphere
Mm-hmm.
because all these don't change too much. So the major the code I use this.
Mm-hmm.
So for sphere, I only need to pass the radium, and all this calculation is made by the macro.
Mm-hmm.
So makes the code a lot smaller.
Yeah.
And I think that's it. Here I have the gazebo tags. If I pass that argument for the simulation, no, if I don't say anything, it will launch like it's running a simulation.
Okay.
But I said that it's not a simulation.
Mm-hmm.
This tags will not load.
All right. I see. I see. All right.
That
That's it. All right. I quite like how you did it. So I'll ask a couple of questions and just get some clarification on some of your
okay.
procedure on how you went about the project. So
Okay.
the first one I want to ask is, did you do Chakra first, or you did a URDF then converted it to Chakra? What did you do?
I did the RDF.
Okay.
I followed the instructions here. I made the RDF first,
Mm-hmm.
and I just cut the things from the RDF and will made a first iteration of the Zacro.
Okay.
And I made some more iterations, adjusting some things like the physical properties macros and this kind of thing.
Right. Right. So
And
was it, did you have to make a description for every spacer? Because I can only imagine there's so many spacers on that robot, right? So
yeah. Uh,
you had to do it for every
that,
spacer.
yeah.
Okay, I see.
Here,
I see.
yeah.
All right, all right. So I think this just highlights how important the chakra file could save you in
Yeah.
cases like these ones where you have 4 spaces, for example, per level, or sometimes 6 or 8, right? If you can have code that recreates each and every one of them without having you to redo everything, it would definitely help. So yeah, but it's good you followed the instructions that were given there. But I think this is one of the big examples of why we need to make use of chakra files. And then the other one that I wanted to speak about is you spoke about using STL. So you had some mesh files that you received. Okay, okay.
Oh, I'm sorry. I have a 3D printer, so the mesh files, the most of times is a STL, but
Okay.
here is not. It's a die file, no?
Oh, okay. All right. I see. Yeah, because
But,
those are given along with the project. Yeah, but all good. So you managed to make use of those ones as well, right? Can you just show me the code section that you did that, if possible, in the URDF?
sorry, can you repeat, please?
Can you show me the URDF code where you put your DAE files, where you included them? Yeah.
Okay. Here.
Okay.
Use the mesh.
I see.
And escape.
All right, and you still on the description you still made use of on the collisions you still made use of basic shapes. I see there is box there and then.
Yeah.
Okay, that's quite good. Any info you can give about that? What benefits do we gain by using simple shapes?
And of course, it said that the basic shapes is more efficient for calculations.
Yeah.
So I know that it's not a complex shape, so use the dot file won't be impacted too much, but I prefer to use the simple script
Yeah,
for this
true.
to remember.
Yeah, true. I liked your first answer that you can it simplifies. It's less computationally taxing.
Yeah.
Right. Assuming you would be working with very um, something that is a little bit complex but can be done with simple shapes, it will be less taxing on your machine if you use simple shapes. So that's also something to take away from this. And then the other question that I wanted to ask you about is for the LiDAR support, right? Can you give some details about what changes you made to get the LiDAR to work with your URDF or to work with your simulation?
I don't have any kind of problem, to be honest, with this. I read on the docs about this error that I am supposed to face, but I didn't face it.
Okay, you didn't have any issues. Okay.
Yeah. I don't know if because I'm using this conditional importing or something, because I don't know if I only test with the real robot with the Zapper files. So this gazebo tags don't influence anything.
Okay.
But I really don't remember this now. But I think that I don't have any kind of problem.
All right. All right. Did you manage to get it spinning? Oh,
Yeah.
and I'm assuming you had to reduce speed to see it spinning, right? Because obviously at the speed at which it spins in real on real robots, it'll be too fast for you to see it in simulation.
Yeah. I read that here.
All
I
right.
use this.
Oh, okay. The one that you're given is the rate. Okay, I see. All right. One more question. Can you give me some information on what your basis for the merge was? Can you elaborate? What did you use? Did you use the base footprint? Did you use the base link? How did you do your merge?
I use the base link
You
because
used
it appears a lot of times,
okay.
and I search some things more than the course itself. So I know that I need this base link, and if I'm running with navigation, for example, I
Okay.
have the base footprint for the collision to the auto algorithm.
Okay.
So I always start with the base link and build the robot upon this.
All right. All right. So you would are you saying you would have to resort to using the base footprint if you're doing a merge for something like navigation or some other.
I already taken the navigation course,
All right.
and
All right.
there
You had to use the base
I have
footprint.
contact with. Yeah.
Yeah, okay. That's the reasoning I wanted you to give out in case anyone who watches might benefit from it. So well done on that
Oh,
one.
okay.
Yeah. Um, I think that's all on my part. Those are all the questions that I had. Let me see if I have one more. Why did you choose to use ROS control?
It's just because I want to build a real robot, and
All right.
I will have to use the ROS2 control. So
All
I
right.
want to know how can I configure and everything using the simulation to don't have this difference between the real and the simulation.
All right. So you basically avoided the other gazebo options for and opted for the
Yeah,
ROS control so that you'd be better prepared for the real robot.
yeah, that's it.
All right. That's quite good. That's quite good. Um, I think that's it from me, Pedro. Well done on this one.
Okay.
Well done, and
So
we're gonna say end our stream here, and then I would like you to hang on for the call so we can wrap it up.
okay.
All right. All right, everyone. So congratulations to Pedro for his project, and if you are keen on doing a certificate with us, please feel free schedule your appointment and book your session with the real robot so you can demonstrate what you have done, and also try all the courses that are being offered for certification. All right, that's it from us, and until next time, keep pushing